Hey, what are you doing?
Oh, well, I can't remember how to make a circuit. Is this something that you can help me out with?
Oh, let me explain that. I can explain that to you.
In order to understand this lab, there are three types of energy that we need to look at. One is chemical energy. That is energy stored in the bonds of chemicals and released in a chemical reaction. The factors that affect chemical energy are the substance that are being reacted and the mass of those substances. Electrical energy is energy associated with the movement of electrons. When electrons move through a wire, that's electrical energy. The factors that affect electrical energy are the voltage of that electricity and the current, the amount of electrons moving. The third form of energy that we'll be working with is light energy. Light is energy associated with light waves. This can include other parts of the electromagnetic spectrum, including the UV light and infrared light. The factors that affect light energy are its brightness and the color or frequency. The batteries we are using in this lab have chemicals inside them that react to form electrical charges. A negative charge is formed on one side of the battery and a positive on the other. That means that batteries essentially convert chemical energy into electrical energy. That's what batteries do. The light bulb in the circuit has a thin wire inside that glows when electricity passes through it. That means that electricity is being converted into light energy in a light bulb. So that's the role of a light bulb, is to convert electrical energy to light energy. It's not enough to just get the electrical energy to the light bulb, though. In order to get electrical energy to convert into light energy, there needs to be a complete circuit, a pathway through the light bulb and back out the other side and back to the battery. Once electrons can pass from one side of the battery through the light bulb and back to the other side of the battery to complete the circuit, then the light bulb will convert that electrical energy into light energy and light up.
I get it. So it's like the role of the wires is to transfer the electrical energy.
The electrons that build up on the negative side of the battery want to get to the positive side of the battery. In order to do that, we need to complete a circuit so that they can go away from the negative side of the battery, through the light bulb, and then back to the positive side of the battery. When the circuit is complete, the light bulb lights up.
That makes sense. So if the wires aren't completing the circuit and touching metal to metal, then the electron's path is interrupted and the light bulb can't light up. I understand how to make a circuit now. Thanks a lot.
Mr. Bingaman, what's going on?
Well, I was thinking that it would cheer this place up to have a little lights hung on the board, but they keep flickering, and I'm wondering, what does that mean? Like, I think I can figure out what this means if I just look at the equations. So, yeah, you understand, right? Right? You get this. It's 110 volts we get out of our outlets, and that's got to equal the current times the resistance. How much current is flowing through each circuit? And in order to do that, I have to use Watt's equation. So if the current is 25 amps and the voltage is 110 volts, so I was thinking that Coulomb's law reminds us that we can't forget Faraday's law. 2,520 volts pushing back on the circuit. Mallory? Senorita Sherwood?
Oh my gosh, what have I done?